Section 8.2, polar form of complex numbers. So here we're familiar with these equations in polar here. X equals r cos theta, r equals sine theta, and x squared plus y squared equals r squared, and tan of theta equals y over x. So we're going to kind of use these ideas to talk about graphing complex numbers. So we're going to need a few ideas first of how do I represent these. But before we get into the formal representation of those, I just kind of want you to think of just a simple complex number like 2 minus 5i. And what I want us to do here is I just want us to graph this, and you'll kind of see what I mean here. So the way I look at this is my real axis, r, and this would be my imaginary axis, I. So we think about graphing it the same way we would the point 2, negative 5, because the real part is 2 and the imaginary part is negative 5. I mean, we still call it x and y, don't get me wrong, but the idea is the real axis is the x and the imaginary, the y-axis is the imaginary. So that's just how we think of it when we're graphing these. But definitely we call it x and y, so be careful with that. But I just wanted to give you the idea of what that meant here. So if I'm going to go 2, negative 5, so that means I'm going to go to the right 2 and then down 5. So it's going to be down here, and I'm just going to do it in a different color here. And my line would be this. And this I would call 2 minus 5i. So that's kind of how it works. That's our point again. So we kind of treat this just like we did when we dealt with vectors. So that's the idea of this. Now we're going to talk about another idea along with this idea here. So then another way to represent this is using this notation, polar form of a complex number. The polar form of a complex number, x plus yi, is, I can actually write it this way. So when we look at this number here, I'm really looking at x plus yi. And like I said, that y-axis is my imaginary part, and the x-axis is my real part. So that's the idea here. So then we could actually write it in another way, which is what we see down here. But one thing we'll need here, if we're going to write it in terms of cis theta, which is a form that when we look at the r times cos theta plus I sine theta, in general, when we talk about that, we call it just cis theta. Okay, so anyways, so now can I write this form 2 minus 5i in terms of cis theta? Now we can, but let's take some simple numbers that we can deal with here that will make this a little easier to understand, and the numbers we get are going to be exact. And then we'll come back to this example here. So let's take this complex number. It's negative 1 minus square root of 3i. So that means I go to the left 1, and then I go down square root of 3. And square root of 3 is about 1.7. So we would get a point about there. So now what we would do is we would just draw our line out. And that vector is negative 1 minus square root of 3i. Okay, what we're going to do now is we're going to actually talk about these angles and everything here. So what we're looking at is this is really my triangle here. And this opposite side here is square root of 3 negative. And this side here is negative 1. And then we can find the hypotenuse, but we would call that the radius, wouldn't we? And we do have our handy-dandy formulas, which are over here to the left. And if you look at that second one here on the bottom, well, the first one on the bottom, x squared plus y squared equals r squared, we can just simply use that to find our r. So then we can find the hypotenuse, and that should be confirming there. It should be 2. Right, guys? Because that is our special triangle. But let's say we didn't know it. So then what we can do here is we could just use -1 squared plus negative square root of 3 squared equals r squared. And I'm just using this formula here, just plugging in my x and my y. So now that's going to give us 1 plus 3 equals r squared. So that's really 4 equals r squared. So r equals plus or minus 2. So again, we're just talking about a radius here, so we're not going to worry about the negatives there. So we're just going to keep it positive here. So it's going to be r is going to equal 2. So then what we're going to do with that information is now we have our r here for our cis theta. Now we have to find our theta. And once we find that, we have everything we need here. So now we're just going to find theta. So this is my special triangle. So I could use cosine, sine, tangent, because this angle here is going to be 60 degrees, and I know that. But that's just my reference angle. I'm really looking for the angle that goes all the way around. So that would be 180 degrees, plus, whoa, I missed something. I know I did. R cis theta. Oops. And yes, I missed an R here. I knew something was missing, and when I looked at it, I was like, there should be an R here. There should be R cis theta. I apologize for that, guys. This here is my cis theta. So this should be an R cis theta. So now back to this problem that threw me off for a minute when I was trying to put it all together. So when I just see cis theta, it just means the inside of this. When I see r cis theta, it means the r on the outside as well. That's what kind of threw me off for a second. But anyways, back to our problem. So that means this then is going to be 2 cis 240 degrees. This would be our answer in terms of the other form. Now to go back the other way, it's actually very easy because once I understand that cis theta is really cosine of 240 degrees plus I sine of 240 degrees. And I just plug those values in. And the cosine of 240 degrees is going to be negative, and it's opposite over hypotenuse. So this is really just going to be, adjacent over hypotenuse, cosine is. So it's going to be -1/2 plus I, and then sine of 240 degrees, that's the opposite. And that's going to be a negative square root of 3/2. And then when we multiply this 2 through here to both terms, it's going to cancel those bottoms out. So I'm going to get -1 minus I square root of 3. So there's our answer, and that's the one we started with. So I was just kind of showing you how they go back and forth. Now, let's take our other. So now let's take this 2 minus 5i. What we're going to do here is the same thing. So I know I have 2 squared plus -5 squared equals r squared. So then this is really going to be 4 plus 5 equals r squared. No, actually this one works out really good. So this is going to be r squared equals 9. So my r equals 3. Now again, I usually could say plus or minus, but I'm just going to deal with the positive r for now. So my r equals 3. So now we're going to have to find our theta. So that's going to be the other side of this now. So we're looking at, if we're thinking about triangles here, this triangle here. So if I find this angle here, I'm going to have to subtract that from 360, because when I go all the way around, that's 360. Now if I take that part away and say, oops, I just want to go to there, it's going to minus that theta from it. So that's what we're looking at here for this problem. So I can say the tan of theta equals y over x here. And my y is going to be -5. So -5 over 2. And here I'll have to do a tan inverse of this here to get an answer. And that's why I didn't want to do that as my first problem. So once I do that, theta is going to actually equal -68.1986, blah, 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 degrees. So now that I have that, otherwise I have to keep the tan inverse of -5 over 2, which looks awful for a theta. That's okay, but it still looks bad. So that's going to be our theta here. So that's going to be this one here. Because remember, tangent inverse for theta runs from -pi halves to pi halves. So that angle we find here is going to be the angle this is. This is going to be -68.1986. That's what this angle here is. Because I went down. So that, I mean, we could keep it that way unless they wanted a positive angle. And if they want a positive angle, I can just take the 360 and minus that 68 degrees. So I'll write it both ways so you can kind of see what it would look like both ways. So for my one answer, and my radius is 3, don't forget about that. So this would be 3 cis -68.1986 degrees. And I'm just going to keep it that way for the sake of writing them all out. And then for the other one, I would have to take the 360 minus, or really if I'm just going to type it in, plus that number because it's negative already. And that would be 3 cis 291.801 degrees. And again, I'm rounding here, so those would be my answers for this one. And just keep in mind too, when I'm dealing with these, I can't have multiple answers. Now, it might ask for something positive, so we would have to go on that one, depending on the directions. So there we go.